I'm calling this lesson 3.5 part 2 because earlier when we covered lesson 3.5 there was a topic that we just did not have time to cover, and that's what we're going to address today. This is the idea, a very important skill really, in how to change a quadratic from standard form, a quadratic equation in standard form, into vertex form. So just for sake of comparison, I'm going to write again the standard form of a quadratic equation in blue. Okay, so the blue represents pretty common, we're very used to seeing this quadratic equation in what is known as standard form. This lesson is on how we can change standard form into what is known as vertex form. And the great thing about vertex form is that it's much easier to graph from. Because if you're looking at a quadratic equation in vertex form, these numbers in the position of h and k represent the vertex. So let me just give you a quick example of a quadratic equation in vertex form. And it relates to our idea of translations that we talked about at the end of chapter 2. Okay, so this is a quadratic equation, quadratic function in vertex form. So instead of having to take this form and do the opposite of b over 2a to find the AOS and then plug that number back in for x to find the vertex, we can literally see the vertex here as 3, 5. H in this case represents the x coordinate of the vertex, h is 3, and k will always represent the y coordinate of the vertex, which is 5. So as you can see, really the preferred form for graphing purposes in most cases is the vertex form. So that's what I want to show you. How can we change standard into vertex form? Well, it involves some completing the square principles. Okay, so remember, in completing the square, in my quantity squared I've already set up, inside that when I'm completing the square, I do the square root of x squared, I bring down the sign, and I always divide this linear coefficient by 2. Alright, so what I've done so far is I've done what is known as completing the square on x. And I just want to double check and make sure that after this first step, and as I go through this, the whole goal is to create an equivalent expression. Okay, it's going to be a different form, but when I multiply it out, it should be equivalent. So let's just take a look and see if that's the case. When I do this quantity squared, I get x squared and then plus 6x plus 9 minus 5. Okay, well obviously what I've done here after I multiplied this out is it's not equivalent. Okay, we can take a look at this and we can say that right now it's really plus 4 on the end. Okay, when I combine like terms, x squared plus 6x plus 4. Well, it's supposed to be minus 5 on the end. So the whole idea here is, if you think of it this way, I'm basically out of balance because I've added this 9 here, 3 squared, and that's causing me to be over by 9. So I need to subtract 9 in order to bring it back into balance, if you will. Okay, so let me just erase this. So when I do this, x plus 3 quantity squared, and I'll show this in 2 steps, but in the future you won't have to, I get y equals x plus 3 quantity squared minus 14. Okay, and you can always double check your vertex form and make sure that it's still equivalent to the standard form. And once again, if I do x squared plus 6x plus 9 minus 14, 9 minus 14 is negative 5. So I am going to have another way of writing this original standard form expression when I combine like terms. So they are equivalent. Okay, so that's the whole idea of changing standard form to vertex form. And what I've done in the past, this seems to help for some people. What you can always do is once you've completed the square on x, well, I'll just show you on another, just a very slight adjustment to this process. I'll just show that over here. Let's try letter B, completing the square on x, square root of x squared, bring down the sign, 4 divided by 2, and then 2 squared is 4. This is another just quick and easy way of getting your final answer. If you can always take this number squared, which is 4, and just think of always subtracting from the end of standard form. Okay, and some people prefer to think of it this way. You always subtract. That's the thing you got to be careful with. It's always subtraction when you're dealing with a positive a number anyway. So here I'm subtracting. 6 minus 4 is 2. And then we need to finish this up. The directions are going to say change the vertex form and then identify the vertex. And so for letter B, the vertex is negative 2, 2. And let me go back to letter A, and I didn't do that over here. The vertex is negative 3, negative 14. Okay. All right, and it's a little different when the coefficient of x squared is something other than 1. So let me show you the difference here. Remember, when you're completing the square, the coefficient of x squared has to be 1. So my first move here, before I can complete the square on x, is to rewrite this so that it looks like this. Essentially, I'm factoring out the 2 for the two x terms. And once again, you can always check yourself with each step. You should just make sure that if you were to multiply this out, if you did take the time, and sometimes you can just do that mentally, will you come back to the original blue? It's just another way of writing the original equation. Okay, now I'm going to complete the square on x, sort of like we did before. The square root of x squared, bring down the sign. 6 divided by 2 is 3, quantity squared. Okay, and I'll just bring down the plus 17. Now, here's where it's a little bit different, because previously I just had to worry about the number squared being subtracted. Well, now, not only is it the number squared, but it's the number squared times, in this case, 2. So if you did have to do some factoring initially before you could complete the square, you got to remember that to make this an equivalent expression, you're going to be subtracting 9 times 2, which is 18. Okay, and so now let's see what our vertex form looks like. Okay, so let's just do a quick little check and make sure that we match up with the blue when we multiply this out. Okay, so I'm just going to write it like this. This binomial squared is x squared minus 6x plus 9 minus 1. Multiply across by 2, 2x squared minus 12x plus 18 minus 1. And now when we combine like terms, we are going to get 17 as our coefficient or our constant at the end. And so I'm feeling confident that this represents the vertex form. And so our vertex is the point 3, negative 1. Okay, this is a problem that was asked about in class, and we worked it together, and I'll just go ahead and throw this in. This is actually one of your homework problems. It's on a separate sheet, separate from your book, and I'll explain that in just a moment. But this is number 30 from a handout that was given. And so the difference here that we looked at is this lead coefficient is actually -2. So let's take a look at how this affects writing the vertex form. Well, to begin with, we still have to make sure that the lead coefficient for x squared is +1. So in effect, on x, we're going to factor out -2. Okay, so if you can see that from line 1 to line 2, I really haven't changed the original function, just the look. Okay, and now I'm going to work on completing the square on x, and that's x minus 3/2 quantity squared. I'm going to bring down the +1. Okay, so remember, I square this number in the parentheses, and that makes 9/4. Okay, and don't forget, I've got to multiply just like our previous example, but this time I'm multiplying by a negative. So it's 9/4 times -2, that's -18/4. Okay, well, unlike the previous example where I multiplied 9 times 2 and got +18 and had to subtract, now I'm multiplying 9/4 times -2, creating a negative number, so we're going to have to add to make an equivalent expression. Okay, so again, 1 is the same thing as 4/4. So 4/4 plus 18/4 is 22/4, and 22/4, well, I'll just write it out and then we'll simplify. X minus 3/2 squared plus 22/4, but obviously this can be reduced or simplified. X minus 3/2 squared plus 11/2, or 5.5. Okay, so this represents the vertex form, and then don't forget to also include the vertex. So our vertex is the x-coordinate will be 3/2, and the y-coordinate will be 11/2. Okay, so I know I've done this one for you. It's one of the homework problems, but see if you can do this yourself without any help, and then you'll know if you got it right just by looking back at your notes. And that's what we've got. Your homework has changed. Let me just mark this out. For this assignment, all I want you to do are 4 problems from your book, page 195. There's 4 problems dealing with changing standard to vertex form. That's 44 to 47. And then I gave you a handout, and I'll post this on Moodle. And the handout looks like this, and I just want you to do, I know the directions say rewrite in vertex form. I do want you to do that, and then go ahead and include the vertex as well. You're doing these problems here, 28 to 33 on that handout. And so you can either pull up that handout off Moodle, or you can just pause the video and look at it from here. Either way, it's a total of 10 problems, 4 from your textbook, and then 6 from this separate handout that I provided. And we will check those next time, and let me know if you have any questions.